In this lecture, we're going to talk about the Cedar Bog Lake application in a little more detail. Um, we have, in the case of Cedar Bog Lake, to model it, we had those 6 state variables. If we look at user inserts for the user code, we'll find that all we need is function state, and you saw this on the slides. So we have 5 different DD equations plus one SS equation. If we use any of the SS variables on the right hand side that we calculate on the left hand side, we have to do the calculation before we use them. So that's why SS6 is first. However, the DD equations are numbered first in terms of numbering the DD array. So we have DD1 through 5, and then SS6 is independent of any of the other state variables, but just kind of a sine wave function depending on T now. So this is typical for a continuous model for the state function. It just describes how the state variables change. In the control model, we have the continuous statement, initial values for all the state variables, the SS variables. And then I've also added a record function to record plots of all of these different SS variables that represent different kinds of components like plants, herbivores, carnivores, and solar energy. So when we run the model, we compile this and execute it. And when we look at the output report, the only thing that we find here is the current value of all the state variables. So SS6 is only expressed as a SS variable. All the others were expressed as DD variables, so we'll have a current value for all of those. So this tells us kind of the values of the state variables at the end of the simulation. These are expressed in energy units per square centimeter. It's a common way of representing energy in the various forms that it exists in, say, not only plants but herbivores and carnivores. We can also look at a graph of the information since we saved that. Let's see. We'll look at the record function. So in this case, I've just saved an Excel file, so it won't show up as an awesome file, so I can't access it through the shell. I can only access it by going to the Excel file that's in the project folder. But if I click on awesome and save this again, then I'll be able to rerun it and take a look at the plot that is generated. So we go from graph, report, graph, plot, and all of the different variables that I collected will show up. So for example, I want to look at the plot for time versus solar energy. Here's the sine wave that we talked about, and this is the value of SS6, so it's, like I said, it's expressed in these energy units. We can also look at some of the other variables. For example, let's look at the carnivores. So these kind of grow from 0 initially, and appear to be, increasing slightly in the lake. These kinds of models are useful for detecting kind of crisis conditions. Maybe the carnivores grow too large, causing the other carnivores and the herbivores to die off, and so we can make adjustments for that. Okay, so please read this section of the text that describes this model, and you can take a closer look. I've also included a couple of other models that just show the difference between difference equations and differential equations, and you'll be able to take a look at those as well. Okay, so that ends the Cedar Bog Lake insert, and